Hello friends, today I will be teaching you, we will be starting operating system. So in today's lecture, we will be studying topic of CPU scheduling. CPU scheduling, okay, and subject is operating system. So today I will be explaining you actually what is operating system and why why are we studying this subject. So imagine imagine if there is no operating system. We will be I will be telling you the definition of operating system, but first learn its real world use. So if there is no operating system, imagine if there is no operating system and we went to buy a computer. So basically what we are buying is hardware, and hardware consists of CPU, RAM, hard disk, keyboard, monitor, etc. Keyboard, monitor, etc. This is what we are buying. But we bought a computer, and then how do we use it? How do we run a program? For example, this is our computer that we bought, and now we had to run programs like we had to run VS Code, maybe Spotify, or maybe Netflix, etc. We had to run this program. So how are we going to use it? How we are going to run this program? So first solution that comes to our mind is we load that program into memory manually, like we use CDs, like we used to use CDs. We used to uh, put the CDs in the CD block, and then we used to run it. Similarly, if we can run our program in our computer, then that way we can run that program in our computer. But this generates a one new problem, which is, what if we want to run all these three programs together, like we generally use multiple application, multiple tabs at the same time. So how are we going to do that? So these are the so we had to come up with a solution. uh, the solution that we arrived to is CPU scheduling, the topic of today. But before teaching you the CPU scheduling, I want to tell you uh, what is operating. Now we know what is operating system. Operating system. So operating system is largely to manage the huge speed mismatch between the CPU and everything else in the computer. uh, Let me write the definition. Operating system exists largely to manage the huge speed mismatch between the CPU and everything else in the computer. And everything else in the computer. So what do we understand by this definition? So basically, CPUs in our computer are extremely fast. CPUs are extremely fast, and everything else in our computer are slow. For example, we are slow, we are slow, and disks are slow. Networks, external devices like printer are slow. Printer, etc. are slow. These are slow devices, and this CPU is extremely fast. I will tell you how fast CPU is in comparison to this everything else, like slow devices like us, disk, networks, printers, or yeah, external devices. But let me teach you how CPU scheduling, about CPU scheduling first, and then we will come to this thing, CPU scheduling. So basically, CPU scheduling problem comes uh, when we had to run multiple programs at the same time. That's when we came to CPU scheduling. But similar to that, what if we have memory sharing problem. We also have a memory sharing problem. That is, like if we want to run those three programs together, like Chrome, VS Code, and Spotify. If we had to run all these three programs together, we came to that we have a CPU problem. Like CPU is running one program at a time. We can only put one program in the in the uh, in the memory manually. So but this generates one more problem, that is memory sharing. That is, even if we uh, put these three programs together, we have a memory sharing program. Like, what if Chrome accidentally overwrites the code menu memory? Like Chrome overwrites the memory of VS Code manually. VS Code memory. So we need a structure of that says that Chrome can't actually overwrite the memory of VS Code. So here we came to three things we had to do. First, we had to learn memory management, how we are going to manage memory of different applications or programs, virtual memory, and protection. Now, another problem that we are going to discuss in this subject is device sharing. Device sharing. Suppose we had a computer and two programs are running in it, and what if, and this is a printer connected to our computer, and what if we want to print, what if two programs print at the same time? What should the printer do? Now, this behavior is elaborated by input output management, the topic we are going to study in this subject, and device drivers. We will discuss two in this subject. The another thing we are discussing, the another problem that is we are going to discuss in this subject is security. Like, if we put a program in our operating system, or like in a computer, so can any program access our passwords? The answer is no. So we are going to discuss how we are going to do this. So we are going to discuss about protection and user kernel mode. So basically, what I told you is operating system. What I told you is operating system. Operating system is that what if we buy a computer, we buy its hardware. What if there is no operating system? So basically, there are four problems that is generated from it. The problem one is, how are we going to run program? How we can run program? So we came to the solution that CPU scheduling is the solution. We are going to discuss this solution in our subject, and this is our first topic. The another problem that is generated if there is no operating system is CPU sharing, and that is memory sharing. How Chrome can, like this operating system, if there is no operating system, then memory sharing problem is generated. What if Chrome overwrites the memory of VS Code or Spotify? So this restriction is managed by memory management and virtual memory and protection. We are going to discuss this topic in our subject. And protection. Next problem that is generated if there is no OS is that device sharing. What if two programs wants to print at the same time? What should our printer do? This comes to our solution. First is input output management, and second is device drivers. And the problem 4 that is generated if there is no operating system is security, such that no program can access our personal or private information. So we are going to discuss this in protection and user mode or kernel mode. So usually, let's take a real life operating system. Actually, examples of operating system. So first is we have listened many operating system in our mobile phone. So first of all, there are skins we use. That is One UI, like One UI, which is its Samsung or iOS, iPhone's operating system. iOS is another thing. Let's discuss first of all Android or Oxygen OS, that is Chinese phone that usually use like Oppo or OnePlus. These are not operating system. These are just skins or on top of operating system. These are not OS operating system. These are skins of our operating system. So what is operating system? Operating systems are, for example, Android. Android is an operating system, or iOS is an operating system. These two are operating system. And Android, for example, if we take Android it is based on this all operating system. This all skin is based on Android, and Android is based on Linux. Android is based on Linux. So yeah. Next thing we are going to discuss is what is process. Process is process. We are going to use this word a lot in our subject. So program in execution state is known as process. In execution state is known as process. So process can wait for input, but CPU never waits, it switches. So for example, if we had two programs running in our CPU, these two programs are running in our CPU, and we write C++ file, and we use scanf to take input from the user, and now whole program was running, and suddenly we had to take the input, and now the CPU will stop. But CPU is never stopped. CPU never stops. CPU is extremely fast and other devices are slow. So we had to do something such that CPU doesn't stop, and it and everything else aligns to the speed of CPU. We had to do something because there would be a huge mismatch of the speed, and we can't let the CPU sit idle for some time just because the user is writing input. User can take any amount to write the input, and we can't just make our CPU sit idle. So we had to come up with a solution about it. So let's discuss our first topic that we are going to discuss today, that is CPU scheduling. Let's write it formally. CPU